We are looking at our review sheet, and we're just going to pick up where we left off last time. Ian, you want to sit down? You're already ready. Sit down.
Yeah.
And we'll go through, hopefully get it all done, and if we get close, we'll stop and see what individual questions you might have. But let's get this guy going here. So we're ready for number 9. Number 9. So we're going to expand to the 5th power. Now remember, what that means is, it's like if you were going to FOIL out 2x plus y times itself 5 times, which would take forever, so we don't really want to do that. So we want to use our shortcut for expanding. Each term will have 3 parts to it. Each term will have a coefficient, a 2x, and a y. Every term that I'm expanding. So, let's do the coefficients. Where do they come from? Pascal's triangle, yeah. And we need the 5th row of the triangles. So the numbers I need are right here. These are the numbers I need. That's the 5th row. So I'm going to write down those numbers. 1, and spread them out because I have some more stuff to put into the problem. So there are my coefficients. Now next to each of these is going to go a 2x and a y. Go ahead and get in the habit of putting them in parentheses, because in a second you're going to put exponents on them, and the exponents go with the whole term, the whole shebang there, okay? All right, so now I need my exponents. Think about doing this. Think about multiplying 2x times 2x times 2x 5 times. Wouldn't you have an x to the 5th? So this guy right here is going to have a power of 5. And then remember what happens to these? They go down. And then the y's do the same thing from the other end. Now, separate your terms. These are individual pieces of the problem. And essentially you're done now, except for the simplify. So when we say simplify, we mean put all of this together. So anything to the 0 is 1, so you can kind of disregard that. What's this?
Oh, what that is?
32x to the 5th. The entire term gets the exponent. All right, what's this going to be? Well, you have a 5, but you also have a 16. So that's going to be 80 x to the 4th y. All right, what do we have here? We have a 10, but we also have an 8. So that's going to be an 80 x cubed y squared. Here we have a 10, but we also have a 4. So that's a 40 x squared y cubed. Now keep in mind, could there have been a number on the y also, like there's a 2 on the x? Could there have been a number on here? And that would mean whatever number it was, like in this term, it would be getting cubed. And you would be multiplying 10 times 2 squared times whatever cubed. All right, what do we got here? 10x, y to the 4th. And what's on the end? Just y to the 5th. because that is one, so we're not gonna let it confuse us, and that is the answer. Okay, it's too big for an answer blank, so tomorrow when you or whenever we take our test, you just do all that, draw a circle around it, and move on. How many different lunches are possible if you must eat a sandwich, a fruit, and a drink? Any thoughts on how to do this problem? How many different lunches are possible if you have to have all three? Kara? It is exactly that. Do I have my numbers right? There are 6 sandwiches, 4 fruits, and 2 drinks. That should be a 2. That's the answer to the question. This is the jumper shirt problem. How many outfits can you make if you have 6 jumpers and 4 shirts? 24. That's it. There's the answer, whatever that is. What is that, 48? 48 different lunches. All right, 5 people in a race. The top 3 are each gonna get $25. How many different ways can the prizes be awarded? 5 C3. Now, when you read that problem, I hope you're thinking either C's or P's. There's 5 people, and you're gonna choose 3. So I hope you're thinking along these lines. Why did he pick C? Because the prizes are all the same. If one guy got 25 and another guy got 10 and another guy got 5, then it would be 5 P3. Find the 15th term of this sequence. Okay, so you're going to have your list of formulas. And we want the 15th term of this sequence. So what are you going, is that 72.9? What are you going to do first? You're going to figure out if it's arithmetic or geometric, right? So I can tell by looking it's not arithmetic. Would you agree with me? Yes. Because we aren't going down by the same amount. If it is geometric, then 90 over 100 has to be the same as 81 over 90. That's what it means to be geometric. The ratio is the same. Is 90 over 100 the same as 81 over 90?
No.
Mm-hmm.
Yes, it is. It's the same ratio.
I'm not sure why you're saying no. Aren't they the same? This is 9 over 10. And if I divide these by 9, isn't this 9 over 10?
Mm-hmm.
Now, you will have a calculator, so what I did was just type the decimals in, or type the fractions in to get decimals. But yeah, those are the same. So, I want which term? The 15th. It's geometric. So that formula says take the first term times the ratio, which is this number, 9/10 is the ratio, to the 14th power. That's your formula. So if you don't, you don't have to memorize them, but you might want to get that list out so you have it. It looks like about 22.877 if I round off. Yeah. There are 137 students in the gym. All of them like basketball, volleyball, or both. 82 like basketball, 77 like volleyball. How many like only volleyball? What? I heard somebody say it. Venn diagram. Anytime, guys, that you have a situation where you've got overlapping groups, in this case, basketball and volleyball, at least consider doing a Venn diagram. All right, what do we know? There are 137 altogether in the box. There's 137 people. Everybody likes something. So there are 0 out here. You do not need to worry about the people who don't like either. There are none of those. They all like one or the other. 82 like basketball, and 77 like volleyball. All right, so imagine this scenario, kids. 137 kids in the gym. I walk in and say, raise your hand if you like basketball, and 82 hands go up. And then they say, okay, raise your hand if you like volleyball, and 77 hands went up. What's happening? That's too many people. So what does that mean? Some of them voted twice. So how many people is this right here? 159 votes, but there's only 137 people. So didn't 22 of them have to vote twice? That's how many extra votes I got. Well, if the whole basketball circle is 82 and 22 of them are already counted, isn't this 60? And this has to be 55. So now we can answer whatever question they ask. The one they ask is, how many like only volleyball? How many like only volleyball? 55. All right, read number 14 and tell me your thoughts. What are you doing? A tree diagram? I think so. Because you've got a couple of different things happening and they kind of depend on each other. So I need to know the probability of me running a mile. So mile, or let's say run, not run. Run and not run. Remember, when you set up a tree diagram, whatever question is asked is the bottom of the tree. So what's the other thing? What's going to be up here on the top of the tree?
75 degrees.
Yep, 75 or not 75. All right, there's a 94% chance that the temperature will reach 75 degrees. So this is 94 and this would be 0.06, agreed? When the temperature is 75, there's a 22% chance you'll run. So there's a 78% chance you won't. If the temperature doesn't, there is a 64% chance you run. So a 36% chance you won't. Find the probability that you'll run. Okay, well, you can run here, or you can run here. So this one is, it's hot and you're running. So what are you going to do with these two numbers? Multiply. So 0.94 times 0.22. Get whatever that is. And then it's not hot and you run. So you're going to multiply those. Now when you run, you're running on either a hot day or a not hot day. So you're going to add those together. So you're going to calculate this, and add them together on your trusty calculator. Okay? I hope you're starting to see that a key piece to all this is figuring out what strategy to use. Because once you figure out what strategy to use, you can pretty much do anything. All right, number 15. A bag contains 3 red, 5 green, 8 blue. How many ways can 2 red, 1 green, and 2 blue marbles be chosen? Okay, so what have I got? I've got 3 red, 5 green, 8 blue. Okay, so here's this bag of marbles. I'm going to reach in and get 2, 3, 4, 5. I'm going to pick 5 of these marbles. So reach in, here they are right in my hand. I want to look in my hand and see 2 red, 1 green, and 2 blue. Any thoughts on that? Well, believe it or not, this isn't like a card problem. Only instead of wanting, 2 jacks and, 3 2s or whatever, I want how many reds? I want to get 2 reds. So there's 3 to pick from, and I want 2 of them, and I don't care what order I get them. I just need to get 2 out of those 3. And I need to get 1 out of these 5. And I need to get 2 out of these 8. That's the answer to the question. Because this bag of marbles is no different than a deck of cards, right? You're reaching in and grabbing some, and this is what you want. Now, this was not a probability question, so that's the answer. Whatever you get when you multiply all that together, that's the answer. But if it had been a probability problem, we would divide all this by 16C5. Now, don't do that. What I'm trying to get you to see is, if it's probability, then what do I divide by? The total? How many total marbles are in the bag? 16? How many total marbles am I picking? That's why that would be the denominator. That was not the question. So the question was just how many ways can I do it? And that's it.
So back to number 14, since that's a probability question, how would we write that?
That's done differently. These are probabilities automatically.
So it's
When you
just the
multiply
decimal?
those, it's gonna come out as a decimal.
Okay.
These are already fractions, 6 out of 100, we're just writing them as decimals. All right, number 16. How many ways can 6 people line up if 2 specific girls must be next to each other? Okay? What are you grinning about? Huh?
Drinking obnoxiously.
Okay,
You're so happy to be here.
yeah, all right.
Shining.
People always ask me, what's your favorite day of the cycle? Day 1, 2, 3, 4. I'm sure you have a favorite. Day 2 is not my favorite, but it gets me through the day knowing you guys are next to last, so I get through the whole day knowing you're ahead of me.
Yeah, that's right.
That's true. All right. How many ways can 6 people line up if 2 specific girls must be next to each other? All right. What if it just said how many ways can 6 people line up? 6 factorial, right? But here's what we're doing now. Here's our 6 people. But we're saying these 2 have to sit next to each other. So they don't count anymore as 2. They have been rubber banded together. So they count as 1. Now these guys are all still sitting wherever they want. So instead of arranging 6 things, now I am arranging, how many? Now I'm arranging 5. I didn't get arranged, they're just together. So it's 5 factorial. But when I tied the rubber band, let's say this is Nyla, this is Nyla, and this is Carol. When I tied them together, I could have tied them together like that, but I also could have tied them together in the other order. So I have to multiply by 2 factorial, which is the number of ways the girls can be arranged. So what if, same 6 people, but now there are 3 boys I have to keep together. Okay, not the girls anymore, just 3 boys. So here's my 6 people, but these 3 boys have to sit together. So now how many things am I really arranging? 4, so I start with 4 factorial, but these 3 can be arranged 3 factorial ways. All right, if Sue ate 32 kisses on the first day, 35 second day, 38 on the third, how many did she eat on the 90th day? All right, let's look at this set of numbers. So we've got 32, 35, 38, what kind of numbers are these? Arithmetic. This is the first day, second day, third day. Aren't we just looking for the 90th number in this list? And the 90th number in this list, it's arithmetic. We have a formula for that. It's the first term plus the common difference times 89. Look at your formulas. Look at your formulas. They should be in your notes. I'm going to give them to you, but you have to recognize them. This is your arithmetic formula. So that's how many candies she's going to eat on the 90th day. 299. Oh. What's the matter?
It's a lot of candy.
I know. It's kind of embarrassing. The candy kisses are my favorite. And over the course of a whole day, I could probably do that. I know. It's so bad. It's so bad. Yeah. All right. How many had she eaten all together after 180 days? Okay. Now, this problem is different because what is this problem asking me? All together, which means I don't want to just list these. Now I want to add them up, and that's a different formula. That is my sum formula for an arithmetic sequence. So I'm adding up 180 of them. I know that the first one is 32. Uh-oh. What needs to go here? No, this is gonna give me the total. How much she ate on the 180th day? So I need to do this, but for 180 instead of 90. So over to the side, this happens all the time. We talked about it. If your formula doesn't give you what you need, go to the other formula. And that's how many candies she would eat on the 180th day. I know, I don't think I can do that, but, oh well. And then that goes here.
It's a lot.
And this then is going to be the sum of everything. This is how many she ate on the first day. This is how many she ate on the 180th day. So we add those together. Multiply by 90. Whoa, whoa, whoa. 54,090.
That's a lot.
That's a lot.
That's a little too much.
An ice cream shop has 8 different toppings. You can get 3 toppings on a sundae. How many different combinations are possible?
24.
Okay, so you go into the ice cream store and they have these 8 buckets of, sprinkles and nuts and whatever you put on it. And you get to pick 3. 8C3. 8C3. Why is it C? Because for normal people, if you put the sprinkles on before the nuts, it doesn't matter whether you, in the order you put the stuff on, right? There are 8 people in the final for the 100-meter dash in the Olympics. In how many ways can gold, silver, and bronze be awarded? 8P3. That one's going to be an 8P3. Because since you are giving them prizes, different prizes for second and third, then order matters. And again, on the test, you're going to type these in. I know you know how to type them in. You're going to type them in and get a number. The answer is going to be a number. Find the sum. Now, what what does the dot, dot, dot at the end kind of clue you into? It's infinite, it's gonna go forever, right? Well, you have one formula that adds up infinites, and it's this one. But in order to use that formula, first of all, you have to have a ratio, so it has to be geometric, and the ratio has to be less than 1. So, can you figure out what your ratio is? What are we multiplying by here? Can you tell? 0.5. If you can't tell, you can do what we did in that other problem, 1.5 divided by 3, 0.75 divided by 1.5, that will always give you the common ratio, but it is 0.5, or 1/2. So my formula says, take your first term and divide it by 1 minus 0.5, or 1 minus 1/2, and I think that gives you 6. The sum of those terms is 6.
Can you use that one when it's getting smaller?
You can only use it, this formula only works if the ratio is less than 1, the absolute value ratio. Yes, the terms need to be getting smaller. If you were asked to add this, you would say, I can't do it. There's no sum. All right, 21. From a standard deck of cards, 2 cards are drawn at random. Find the probability that P stands for probability. So find the probability that both are aces or both are black. Okay, what does the or kind of clue you into? Would be an addition. So we'll do 2 separate problems here. So what's the probability that I will get 2 aces?
52C4.
What?
52C4.
That would be picking
Or
4 cards out of the deck.
4C2.
4C2 over 52C2. Now, why is the top 4C2? Because there are 4 aces and we are picking 2. Why is the bottom 52C2? Because there are 52 cards and we are picking 2. So this is going to be something. All right, now both black, 2 black cards. What's that going to look like? 26C2 over 52C2. Why 26? Because there's 26 black cards in the deck, and we're picking 2 of them. This problem is incredibly tricky. We are not done. There is something fishy. Can anybody think about what's fishy about this problem? Well, it is an or, so I'm going to calculate these. I'm going to add those together. That's for sure. No, and I don't have that up here. So I'm good. This is definitely the probability of both aces. That's correct. This is the probability of both blacks. That's correct.
Can you not have the 4 aces be a part of the 2 blacks?
Oh. Let's look at this. This is 2 aces, right? Does this probability include the ace of clubs and the ace of spades? This probability right here, does that include that? It does. All right, let's look at this. This is 2 black cards. Does this include the ace of clubs and the ace of spades? Wait, 2 black cards? Aren't these both black? Isn't that included in this one too? Well, you can't include it twice. That kind of weights that one more. You can't do that. So, we have to take both aces, both blacks, and then subtract the probability of black aces. because the black aces, that pair of black aces, has been counted here, and it's been counted here, so we're gonna subtract it out. So what would that look like? 2 black aces. 2C2 over 52C2. Because if you want 2 black aces, aren't there just 2 to start with? And you're gonna pick them both. So this happened, very weird problem, but it's happened. This happened because there's overlap between these 2 sets of cards. If I had said 2 diamonds or 2 hearts, would I have to worry about this? No, because there's no overlap between these. If your 2 situations have overlap, then you need to subtract that out. All right, I'm going to type that in just so we have a number to look at. It'll take me a minute. Oh my gosh. I got something bigger than I thought. I got .2488, anybody, or 2489. Anybody else get that?
Yeah.
Okay, it's higher than I thought actually.
Miss Ford, can you type the whole thing in and then put it over the denominator?
Absolutely can, that's what I did. So, since these all have the same denominator, just type in the whole numerator and then it equals, and then divided by. Yep. Don't do that if they have different denominators. All right, B. Find the probability of both threes or both face cards. Okay, both threes. Won't both threes look like this? What will both face cards look like? 12C2 over 52C2, both face cards. Is this problem going to have a subtraction?
No.
Is there overlap between threes and face cards? No. So that's it. Whatever these are added together, that's your answer. You see the difference, guys? Okay. So how about C? Both black or both kings? Isn't that one going to be just like A? Because both black and both kings, you're going to do exactly like A. So you'll find the both black, you'll find the both kings, and then subtract the black kings. So A and C, boys and girls, are exactly the same. Setup, answer, everything is exactly the same. Okay, finally, I've got 4 red, 9 blue, 7 green. I'm gonna pick 3. I want the probability, that's what those P's mean, probability of getting all red or all blue. What do you think that's gonna look like? All red, all blue. 4 what?
C3
C3
plus 9C3
plus 9C3.
all over 20C3.
Why 20?
That's what Zero item.
That's how many pens you have. So your denominator is total. 20 pens total, picking 3. Order doesn't matter, just pick 3 pens. Does that make sense to everybody? All right. At least 2 blue. At least 2 blue. What does that look like? What does that mean, first of all? At least 2 blue means 2 blue or 3 blue. Now, will my denominator still be 20C3?
Yes.
And the or means I'm gonna add. And 3 blue, I think I already did. Is that 9C3 for the 3 blue? Now, here's the tricky one. Because 2 blue, you're gonna say 9C2. But what else?
2C2.
11C1. Why do I need to include an 11C1 with my 9C2? Because I'm picking how many pens? 3. And if 2 of them are blue, then what's the other one? Not blue. And there's 11 not blues. And I need to pick one of them. That's tricky. I mean, it's obvious now that we talked about it, but it's easy to overlook. You're picking 3 pens. If 2 of them are blue, then you must also pick a non-blue. Okay, add all that up. That's the answer. Exactly 2 blue. Wouldn't this right here be exactly 2 blue? Just that part of the problem? That makes sense to everybody? All right, I'm gonna hand back some quizzes and whatever, I don't even know what I got in this pile. And then, we're gonna answer any questions we have about any of this stuff. So, for example, I'm handing back homework papers, and some of them have marks on them,
There's 2 in there.
which means that we have issues. So, let me get these handed out. What? Leave your phone here, and please hurry up. This is a free time, we're supposed to use it as productively. Page. Emma. Amanda, Laura. Dave's not here. Jay is not here. Amanda. Please look over these papers, guys. I don't want you making the same mistakes on your test. So look them over. Jaden. Robbie. Put your phone away. Sydney. Nyla. Sharon. Brayden. Darryl. Robbie Rapp. Kamar and Sue. Kendall. Sydney, Emma,
We're not counting home marks.
Alex.
Okay, we gotta avoid that score. I got 14.
All right, that's everything I've got. So take a minute, look those things over. We have reviewed, you're taking a test over this tomorrow, or Thursday, whenever. So you should be able to figure out what you did wrong. Figure out why things are marked wrong, if they are.
It's on me.
No, you're good.
It's my bad then.
Alright.
Let's be real. That's how many players.
All right, has anybody found something that you're not sure why you missed?
On the quiz, number 4.
A 5-card hand is dealt from a standard deck. Find the probability that contains exactly 2 aces. Now, Brayden, do we care? A 5-card hand, 2 aces. Do we care which aces we get? No. We just need to get 2 aces. So, how many aces are in the deck? 4. So we're going to start by saying we need to get 2 of those 4 cards. Now, it's a 5-card hand. So we need 2 aces and 3 other cards. And the 3 other cards are going to come from the non-aces. So that's your setup right there. Now, I didn't look carefully at yours, but it looked like you did like 4C1 or something. Those are specific aces. When you do 4C1, you're saying you want the ace of diamonds, and that isn't the problem. I want any of these 4, any 2 of those 4. Okay? All right, anything else? As you look through these homeworks and stuff. Nyla?
Shoot 3, right? It's you.
Number 1, part B.
So look at it. Okay, 9.3, number 2, which one?
1, part B.
1B? All right, I probably have to do the whole thing. We have 2 cookie jars on the counter. This is a homework, 9.3, number 2. There are 2 cookie jars on the counter. The blue one, so we have a blue cookie jar, and we have a green one. So I walk into the kitchen, I'm gonna have a cookie. First thing I'm gonna do is decide I'm gonna get out a blue jar or the green jar, okay? The probability of each is a half. They're just sitting there, I'm just gonna grab a cookie out of the jar. The blue one contains 6 chocolate chip cookies, so I'll say chocolate chip, and 8 sugar cookies. So 6 and 8 means how many cookies are in the jar together? 14. So 6 14ths and 8 14ths are my probability of getting a chocolate chip or a sugar out of this jar. Now, the other jar has 2 chocolate chips and 5 sugars, so 2 and 5, 7, only 7 cookies in that jar. What is I go in and grab a cookie. What is the probability it'll be sugar? Well, I can get a sugar cookie out of my blue jar, so blue and sugar, whatever that is, or I can get a sugar cookie out of my green, so green and sugar. So that is I have your paper, sorry. That is the answer to the first problem, whatever those 2 things are added. Oh, let me write down the problem here. What is the probability that if he chooses chocolate chip, it came from the blue jar? So what is the probability of blue given, no, what is the probability of, blue given chocolate chip? Okay, so let's read the question. What is the probability that if he chooses a chocolate chip cookie, it came from the blue jar? So, I walk out in the hallway with my chocolate chip cookie, I pick the chocolate chip cookie. What's the probability that I got it out of the blue jar? Well, there's a formula for this. This would look like, what's the probability of blue given chocolate chip? And that is the probability of both divided by the probability of chocolate chip. So the probability of both of these, blue and chocolate chip, divided by the total probability of chocolate chip. Now, blue and chocolate chip would be right here. So that would be 1/2 times 6/14. That's 3/14. So your numerator is 3/14. Blue and chocolate chip. Now you could get a chocolate chip out of the green jar though too. So that would be 1/2 times 2/7 or 1/7. So this one was, what did they say, 3/14? And this one right here is 1/7. So I need to add those two together. So 3/14 plus 1/7 is 5/14. And that's my denominator. So the correct answer is 3/5. All right, anybody else have a question about a paper that I turned back?
Can we do?
This is almost exactly the same question. This one says, okay, I'm doing, meatloaf and mashed potatoes. So, meatloaf or no meatloaf, potatoes or no potatoes. Okay. So if grandma serves meatloaf, this is out of the same homework assignment, there's a 74% chance that she'll serve mashed potatoes. If she doesn't serve meatloaf, there's a 47% chance. She serves meatloaf 22% of the time. So that is the, just the setup in general. Now the second question says, find the probability that if grandma serves potatoes, she also served meatloaf. So find the probability of meatloaf given that she served potatoes. That's what we're finding right there. So we just did that. Our formula for that is, this is the probability of meatloaf given potatoes. So our formula would say the probability of both over the probability of potatoes. So how do we know both? Well, that would have to be meatloaf and potatoes. So wouldn't that be these two times each other? So that is 0.22 times 0.74. So that's 0.1628, and that's my numerator. That's both. Now the denominator is all of the potatoes, which includes this, but it also includes this, 0.78 times 0.47. So this is meatloaf and potatoes. This is no meatloaf and potatoes. So the total potatoes is those two added together. which is 0.5294. So your answer is gonna be whatever those two things divided by each other are. That's the calculation. All right, time for one more. Anything else? All right, we have tests next time.